Hi there, my name's Nick Schultz, and welcome to Getting Started with Storyboard. I'd like to thank you all for taking the time out of your days today to join this webinar. And few things before we really get started. But if you are connecting today and perhaps having some issues with audio, there's a couple settings you can try on the GoTo webinar panel on the side, or if you're in the web client. And you can submit questions to the Q&A chat, and we will answer them as we go through. Generally, these will be addressed at the end of the session. So if you don't get a response right away, don't feel that they've been missed or anything like that. And then finally, if you're looking to follow along with sort of what we're doing, how we're putting out content today, you can go to Twitter and check out some of our hashtags, hashtag embedded GUI and hashtag crank storyboard. So as I already said, my name's Nick Schultz. I'm a field applications engineer at Crank Software. I've been with the company for about 5 years now, and before that was a HMI developer in the automotive sector as well. So I've got sort of a wide variety of experience in the embedded space, and pretty excited to talk to you about Storyboard and how we take a very interesting market and put a creative solution to it with our product. So first thing, as you're seeing right now, we're in a slide deck, so we're going to kind of have a little bit of an introduction to Crank Software, who we are, what the product Storyboard is, where we come from. And then we're going to go through and we're going to talk a little bit about, how to get Storyboard up and running. So I'll show you where to request a download link and have a free trial of our software. We're also going to walk through the tool. I'm going to import some content for you. I'm going to hook it up, add a little bit of behavior. Then we're going to prepare it to export to an embedded platform that we have. And then I'll show you that via webcam. And we're also going to walk through some of the deployment steps, as well as what's living on the embedded hardware system. So if you're really looking to start playing around in prototyping, you could download one of the demo images off of our website and do exactly what I'm doing today. So a little bit about us, Crank Software. We are a privately held product and services company in Canada's capital, Ottawa, Ontario. We've been around, founded in 2007, so I guess that's roughly 13 years now, and built on top of an extensive amount of experience in the embedded and graphics space. The three founders who joined the company all had specific skills working at a real-time operating system company beforehand, and saw a real need in the marketplace to help build tooling to help solve the problem of creating rich interactive embedded UIs on resource constrained embedded operating systems. We've got a global partner network with distributors and a couple other remote staff across the globe. We work very, very closely with some of the top silicon vendors. So you can see here NXP, ST, Microchip, TI, Renesas, some of the SOM vendors as well, Toradex. So we have a very strong coverage in terms of the embedded hardware available on the market. And if you haven't heard of us before, I almost guarantee you've used a product with our software running in it. A conservative number that we have is more than 500 million devices shipped in the field, and we are in a wide range, really anything that has an embedded display, and that could be a touch power display or something using hardware, or even a combination of the two. We build some pretty compelling products in that space. We've recently won a number of pretty prestigious awards that we're quite proud of. We've won some innovation awards with some of our partners at CES, a Supplier Innovation Award from a company you may have heard of them called John Deere, as well as Company of the Year in Ottawa, as well as the Innovative Software Award at Embedded World 2020. So we're coming off of a very strong year and very excited about what the future holds. Some of the customers that we've worked with, I mentioned before, you may not have heard of us, but I'm pretty sure you've probably used our software at some point. But you can see here there's a wide range of different products, from heavy equipment, you can see at the top John Deere, home thermostats, some cooking devices like the Thermomix from Vorwerk, cycling computers, high-end cooking ovens, see a GE profile oven there, even into automotive and some of the motorsports space with some aftermarket motorsports clusters or some clusters and infotainment systems shipping in vehicles today. So really, how Storyboard helps and why we are, why we're doing what we're doing is, if you think back, when the iPhone came out and the concept of mobile devices and user interaction really turned on its head was around the time that we were founded, around 2007. But all of a sudden, the emergence of that technology, everybody with a display panel started expecting that level of interaction on their devices. And whether that's fair or not, devices that are what we'll call embedded, that aren't running the latest and greatest mobile processing power, are still judged based on that benchmark of the really high powered silicon that we all carried around in our pockets, whether it be an Android or iOS device. So the first thing is the product Storyboard that we've developed helps you build a UI that provides an experience like that. But there's another few other things that we do, and we do very well. The first thing is we really help to accelerate development. And as you see when we do a technical demo and I jump into the tool, we take a very different workflow. And what you may be used to with other frameworks or tools are very much a software library and language. Maybe some tooling solutions to help you visually lay out some stuff. But for us, we really help you bootstrap your UI and develop it rapidly. In terms of iterating, we also really believe that you're not going to get the perfect design the first time, and you need to be able to test it, iterate, and change it. So that concept is baked into our tooling, and as you play around with it, you'll see that what you build up is really something that's flexible. You can iterate on it, you can test it, you can prototype it, and then you can make changes. So you can be sure that you are delivering the best product when it reaches market because you've put in those testing cycles. And finally, flexibility is something that's very important to us. It's not as if when you're in the embedded space that you're targeting a mobile phone and your specifications up front. Sometimes you're unsure of your hardware selection, and you might be evaluating a couple different boards, maybe a higher end for a more premium product and a mid-range or low power solution for a entry-level product. So our tooling allows a great deal of flexibility, and we really aim to help scale the ecosystem. So going from a low power MCU platform to a higher power MPU that might have 3D acceleration, our tooling helps you bridge that gap. And we are very, we believe very strongly that you need to be able to build up a UI regardless of having the tie into that hardware. So treating it, sort of as an agnostic piece, and then allowing you to build up your UI in isolation. So we'll play around with that, and I'll explain to you a little bit how that works. But I talked sort of a lot on the last slide, but really, a big differentiator is we're not a code generation framework. What you're going to see today is I'll be walking through the tool, I'll be importing some design content, and I really won't need to have any software development background. And this is very powerful because it allows people that might be on the design side of the equation, or maybe coming to this space from what I'll say is a higher level of development experience. So maybe some web-based developers where the constraints of running on an embedded system aren't as familiar to them. So they can get in and really bootstrap, build up the design, create behaviors and really own the experience without having to handle a lot of the low-level embedded development. We also decouple the UI from back-end logic, and this is a pretty powerful paradigm because you can have your back-end core application team working in parallel to your UI design team, and that way instead of having this sort of lockstep development cycle where UI develops something, you hand it off to engineering, and then rinse and repeat on that. You can both iterate in parallel, and we decouple this with an event structure, so that way when you drop your UI onto the embedded hardware, it's really more of a connecting the pipes, if you will, ensuring that the data coming across from each end is sane, but the interfacing is already put in place and it works. We really want to embrace that design change. So again, as you're testing on hardware, you can fine tune your behaviors, your transitions, your animations to ensure that the experience is really tuned for your platform. And we really make that easy. And finally, we really take advantage of the features that are available on the hardware platforms. So I mentioned earlier, perhaps there is 3D acceleration available on your board. We can leverage OpenGL to help accelerate and offload the CPU. The same thing holds true for some of the lower powered MCU platforms that might be running an M4, M7 core. Some of them have 2D accelerators, and in that case, we can also leverage that to help offload the CPU and accelerate some of the graphics and rendering. All of this is done internally by us. You don't need to worry about that. So again, you just get to focus on building up your UI. So a lot of words there, but this is where I like to drop out of the slides and get right into the meat of the demo. So I'll just exit out of that. And the last thing I'll do before is, if you were looking to download our software, it's very, very easy. Just go over to cranksoftware.com, and we have a getting started section right there. And you can get a free 30-day trial. It's not limited in any way. We want you to play around with the tool, and all you need to do is fill out a few pieces of information. And then once you do that, a download link and a evaluation key will be emailed to you. From there, you'll have the option of downloading an installer for Storyboard Designer, and that runs on Mac, Linux, and Windows desktops. And that will leave you with, what you see here. And I'm running on a Windows desktop, so you'll see, when I interact with things, I'm in the Windows environment, but the same thing holds true. So you can have teams with multiple people on different operating systems and development machines working in collaboration. So now that we're in the tool, the first thing that I want to kind of highlight is, on your first install, after you've entered in your eval key and you've set everything up, you'll be greeted with this view. And this is the welcome screen. You've probably seen it on a lot of different products and platforms, but it's got some links to different sections. So, tutorials, documentation, our support channel, getting started videos, those are all really helpful things. So after you've played around a little bit, you can always revisit them. Especially the getting started section in our knowledge base. There's a lot of really good videos that are going to highlight and cover some of what I show you today. But if you close this view, you can always reopen it from the help menu and select welcome, just in case you're wondering how to get back there. So this is our empty environment, our development tool, and there's a few things that you can do to get started. We ship a number of samples with our platform, so file, new, storyboard sample, and this is going to open up a dialog, and you can see here there's a good number of different samples, and all of them cover specific topics or elements of things that you might want to see. Some of them are a little bit more generic, like the address book sample kind of shows you how you build up a small application, but also has a few different elements inside of it that are useful. So scrolling tables and lists, using our scripting language, how to interface with data and modify it. So that's always useful. Other things might be a little bit more focused. Virtual keyboard, for instance, is really that. It is a virtualized keyboard, but it also shows, how you might handle some multiple languages and different character sets. Finally, if you're curious about how you interface with external processes, I mentioned that we offer decoupled UI and architecture. This cluster IO application shows you how to receive messages from an external source. And we also have something that's a little bit more fully fledged called thermostat IO that has a bidirectional communication, so sending and receiving messages from a sample C program. So both of those IO samples have some sample code if you're looking to build and compile that and play around with interfacing to your embedded system. You can do that as well. But I'm going to actually open up a new design file, and you can do that a couple different ways. So we have this new project from Photoshop content or an icon in our toolbar at the top. I'm going to click that. I'm going to navigate to one of the Photoshop files I have available to me. And this is really powerful because a lot of our clients and people that we engage with are working with design teams who are mocking up, look and feel of user interfaces. And we have a few guidelines that you can follow, whether you're using a tool like Photoshop, or we even support the Sketch tool as well, that if you follow a few naming conventions and hierarchy layouts, you can actually build up a fully fledged design that after we import it, will look at there we are. Sorry, the audio glitched a little bit there. So as I was saying, yeah, you can import a Photoshop file, and this will go through and actually, import as it is in the design file, allow you to really bootstrap interactions without having to lay out any images or text elements. So I'm going to select that file. This is just sort of parsing the file, grabbing some pieces of information from it. So you see grabbing the name there. And we can just import this as is. Before I do that, I'll just call out, there's a couple options here. The first one that I've ticked is making sure that we import Photoshop text layers as editable text in our tool. If you didn't tick that, it would mean that all the text might be baked into images. And maybe this makes sense if you're running on a really tight resource constrained device and you're only supporting one language. But I suspect in 99% of the cases, you're going to want to have control over the text content. You can also, give the project a name. I'll leave it as is for now. Or you could import content into an existing project. So maybe you're working with a design team that are building up different screens or pieces of information as as you're working away. You could then import that content piecemeal through these options down here. But once I hit finish, we're parsing the file, and the tool is actually slicing up all the image assets for us, which is very nice. If you've ever worked in the UI space or building a user interface application before, it was probably common where maybe you'd receive an archive of sliced up images, JPEGs, PNGs, other assets, and you might have to lay them out yourself. In this case, the tool did everything for us. So, a couple seconds, we imported it, and we have 6 screens here. You can see here, we've got this sort of home security, home automation type panel, thermostat, weather, setting screens. So, that's already coming for free. And because of that, we can start looking at, the hierarchy and the structure and how we want our UI to behave. So, the first thing that we see here is now that we've imported our content, our model view on the left, and this is the structure of the application, is fleshed out. And there's a hierarchy to this. If you think of a tree structure, the root node or the topmost piece is the application, and that holds information about the name. You can call this whatever you like. It's defaulted to application. The resolution, color depth, information like that. And from there, your app can be made up of one to many screens. And a screen is what's going to be showing up on your display at any given time. And you can see here, a screen, you can almost even think of it as, a state, if you will, or, a certain endpoint in your UI. The screens themselves can be made up of one-to-many layers. So if I expand this section here, you can see here, we've got the concept of layers, and layers have the ability to be shared across screens. So you can start grouping like content together. So a good example might be the menu layer. You see there where I hid that, and our menu bar and logo have disappeared. But this happens once, but it's shared across multiple screens. So if I were to drag our logo out and scroll up, you can see here that that change has been propagated to every other instance of the layer. And that's, very powerful, and we're really big on reusing elements that you've built and created. And, we really encourage that type of design and behavior. So we want you to build up your content in reusable ways and combine them together. Another element that might be shared, and it's not visible right now, but we have a scrolling menu that we could pop in from the left, and then the background layer as well. Sort of that's a generic image and texture. So, reusing these elements will save you, it's more efficient. It'll save you space on your file system or in flash storage. It'll also save you memory, since you can have them defined once and instance in multiple places. And it really helps you build up your UI quickly and easily. Finally, within each layer, you have the concept of controls. So our menu layer, you can see here, we had our Crank Software logo, and this control is an element on screen. And all controls in computer graphics, well, control might not be the right word for it, but elements, anything that you need to display on screen have some elements, an X, a Y, a width and a height, so it's all based on a rectangle, and this is what determines where we're rendering content to the display. And you can see here, our logo has an image property to it, which we call a render extension, but it could also have a combination of other elements. You could add text to it, you could add filled blocks, circles, arcs, outlines, what have you, 3D content if you wanted, and then you can build up your hierarchy and your effects that way. So now that I've sort of given you a quick high-level view of what the hierarchy of the app is, let's actually start adding some behavior and doing something. The first thing I'm going to do is I'm going to take our thermostat screen. I'm going to set that to be our starting screen. So if I tick that, this is going to be the first screen that we see when we launch our application. And if I were to hit our simulate button there in the top left corner, save the change that I made just there, we can actually run this application in the desktop environment. And the cool thing about that is this is the same core code that's going to be running on the embedded system. So everything we do and we play around and test with here is going to run the same on the embedded hardware. And you can see that we have our start screen, and there are also a few behaviors already hooked up for us. When I click these plus and minus buttons, there was a few naming conventions specified in the design file that tells our tool to wrap the behavior of a button. So again, we've bootstrapped all the button behavior, sort of that press, release, outbound type interaction, and already handled that at design time. So we don't have to worry about hooking that up, which is very nice. What that looks like if we were to select this element here, and in our actions panel at the bottom, another important aspect is you can see here our events, our press, release, outbound, trigger our actions. And this action, in this case, it's a data change, so it's just flipping the state of an image. We've got the plus up and the plus down image, so it's swapping that out. And that is how you start adding behavior and interaction into your application. Storyboard is completely event-driven. What that means is, we require an event to happen to take an action. So an event could be user input, press, release, outbound. It could be the completion of a timer. It could be even a custom event that you design yourself. So if you think of this thermostat application, it could be an update event coming from a temperature sensor to tell the thermostat that, hey, the temperature in the house has gone up. Or maybe if we were to look at our weather screen, maybe we're getting an event from an external weather source. You're calling out to the weather network or something else. You could get your updates here. So, with that in mind, the event model and how you interact with things determine what you do. And the actions are, exactly what they sound. The action is a definition of what change or behavior you're doing in the UI. So the first thing you might want to do in this case is hook up some transitions between screens. So we'll go ahead and we'll do that here where we have our thermostat button. I'll right click and say add an action. And this is where we can select our event to trigger a behavior. So in this case, you can see here there's a list of pre-available events, Android lifecycle events in case you wanted to export on Android, focus events. If you're building a UI that doesn't have touch and is you're navigating by hardware keys, so when a UI gains or loses focus, you could key off of that. Gestures and a whole bunch of other things. But in this case, I want touch, which is the combination of press and release on a same control. And then the action we want to do is a screen transition. And if I scroll down here, you can see I have a list of transitions available to me, some with 3D effects, others more subtle, like a fade or a path. So I could select a fade here. And then we pick out our new screen. So the next thing that we do is, as you might expect, we have this drop-down menu, and we can choose our destination screen. Since we've clicked the thermostat button, we're going to select the thermostat screen since we want to always drive the UI to that screen regardless of where we are. Hit finish. And we're going to go ahead and do the same thing for the weather element. So add action, touch, screen transition, select weather, say OK. And finally, we'll do the same thing for settings, just so we have a nice 3 elements at the bottom. I could even shortcut this and right click and say copy and paste on the new control in case you were looking to save a few clicks. And then all I need to do is update the property on the right where right now we are selecting weather. But again, I will say go to our security page. I'll save that. And now we can quickly test, simulate this again. And you can see here, I click these buttons, we transition to the different screens, nice faded blending effect. The setting screen, our buttons have been hooked up for us as well, which is nice. So we're very quickly and easily building up behavior in the UI. So that's neat. The other thing that's always fun to do, and really what helps add that extra level of polish to a UI, is being able to build animations. And animations themselves are, something that could be very, very simple, just sliding an element. So, really a change of a property over time, or it could be a combination of many changes over time that are staggered and nuanced. And to help accommodate for that, we've actually built in a timeline tool in our environment where you can piecemeal build up very, very complex and fancy animations. And when I swap to the webcam and show you one of the demo images you're running, you'll see that firsthand. But the other thing is, we want to really help ease the process of creating animations. And if you've ever built them up programmatically, you could probably understand how you might be given a video and you need to try and recreate that and trial and error with all the timings. But it might be easier to just change some elements in your tool and then have the tool sort of watch what you're doing and bootstrap an animation for you. So we've actually built that functionality into our system. And a really good example for that might be our scrolling menu layer that I mentioned earlier. I've got a couple elements here that are off screen, negative 290. So if I were to set that to 0, you can see there's one button. A few of the other ones are also hidden. So I'll reset that. So the first thing I'll do is I'm going to go ahead and I'm going to group these elements. I'm just going to right click and say add group. And that way everything is now contained. So I only need to update one property. But if I were to slide this back to 0, you can see here we have a full slide out menu. And that, could provide another set of navigation. Maybe it could be context specific. So depending on what screen you're on, when you pull it out, there's context specific options. But that's up to you to decide how you want your application to behave. But the first thing we need to do is handle hiding and showing it. So if I go back to where it was, so 290 offset, and take a little button in the toolbar up here, this green circle with a camera. When I click that, you see we have a red border around the UI window. And now we're starting to record changes that we make to the model. So in this case, I want to slide our element out on the x-axis. So again, resetting that to 0. And then I can close off our animation. Before I do that, it's important to call out that if you wanted to build up multiple steps, so maybe you could have this slide out while sort of a semi-transparent background faded in over top of all of your other elements, you could do that as well. You could start taking snapshots and that would start building up frames or steps, if you will. But for now, I'm just going to keep it simple. Close that off. We'll create what's our new animation. We'll give it a name. So I'll say menu open. You can also choose its frame rate. If you want 30, 60 frames a second, if you want it to loop on itself, if you want to use delta values or absolute coordinate values, I'm going to leave those as is for now. And you can see now that our UI, everything's been reset to what it was. And we have this, this step in our timeline. So if I hit this little film strip icon, you can see here we now have one animation entity. And if I drive into that, this is where we can start building up the nuances in the behavior. The first thing that I want to call out is that the tool does a best guess at what it's adjusting. So in this case, it's going to choose a 500 millisecond duration, and it's adjusting the X property of our control. And you can see here, this is the fully qualified name and path to the control. So our scrolling menu, layer, main menu control group, and then the X coordinate there. And it's going from the current value when the animation runs. So, maybe you've got an animation that you're, dragging out manually. So you could set it to be whatever it was last at, to 0. There's also a few other options. If you're curious about, easing rates or things like that, you could adjust them here. But we can also preview what that looks like. So, when I do that, I can see that, it's a linear rate, it slides out, nothing super exciting, but maybe I wanted to speed it up a little bit. I can drag that down and also do an ease in, so it sort of snaps in. Preview that again, and it's a little bit more snappy. I think I'm happy with that for now, but it's important to note that you could also create your own custom rates here by dragging these end pieces out and saving them to be anything you like. So again, there's a lot of flexibility in what you're doing and how you want to go achieving your goal. But the animations are where you can get into really fine-grained detail and really add that extra level of polish to your application. So now that we have our animation, we can actually go and trigger it. And if you're following along, you've probably guessed that I'm going to need an event to trigger this animation. So if I click on our little hamburger button menu there, and maybe I'll just make it a little bit bigger for the embedded target. Just drag that out. So again, this is, this is our touch zone. I'll go ahead and I will center that. There you go. So now that we have this bigger zone here, we can right click on it, add an action, again selecting our touch event, but instead of a screen transition, we're going to select an animation, and we can select the animation that we have in the dropdown right there. That's awesome. If I save that and we run it again, you'll see that now when we press this element and just calling out the fact that I made the touch zone bigger, I can click here and our menu snaps out. The one thing we haven't done is we haven't closed it off yet. So even though we've engaged it, we need a way to snap it back in. So you might be thinking, okay, that's super easy. I'll go adjust the coordinate space of the group and re-record. But we also have another shortcut element here where if I were to right click on this and say add reversed animation, this will actually flip the animation for us, and I'll give it a name like menu close. Say okay. And now in our group, I can select, I'll take the top control there, and it's off screen, but it's the one that has the X on it. And then I can say right click, add an action, touch, animation, close. Hit finish. So if we run that again, we now have our animation snapping out, and it now closes out with us. And the really neat thing that I haven't really explicitly called out, but is sort of implied, is that whenever we hooked up our behaviors onto these menu elements on the layer, we did that once, but that layer is used on every screen. So regardless of where we are, we can actually benefit from those events. So you're sort of doing it once and reaping the benefits in multiple places. The same thing also applies for other elements as you're walking through. So again, keep that in mind as you're building up your application. But some of these layers, as you go through and share them, you could add this menu layer to other screens, and then you could also benefit from that behavior as well. But I think we're at the point now where we're pretty happy with what we've done. And it's now time to talk about how do we get this on our embedded hardware. And that's really that last step of iterating, prototyping, and validating your solution is you want to test and run on your hardware. So what I have with me here, and I'll just quickly enable my webcam for you so you can see. Webcam, perfect. And I will go ahead and I'll just stop showing the screen so it's full screen there. But I have one of our evaluation boards ready for us. I'll just trigger the lights. And this is actually, unfortunately, you can't see it very, very well, but there's a IMX8, so the NXP 8M Mini running there. And this is available as a demo image off of our website. We also have the Nano. And this is a really good board to play around with and prototype on. It has 3D graphics, OpenGL acceleration, but you can see here as I'm touching different elements, we're swapping around. We can launch our application there, so it's going to launch another 3D demo. So we've got a nice sort of robot arm here that we can interact with, do different animations here. There you go. But this is the hardware that we're going to get ready to deploy on. So the board is actually a Linux system. I'm just going to stop sharing my webcam and switch back to my screen. There we go. So the board's a Linux-based system, and I have a terminal connection open to it. You may have seen when I had the webcam on, there was an IP address available. So if your board has network connectivity, you can do that there. But the first thing you might want to do is get the IP address, which is available here if you run the ifconfig command. So 172.16.0.116. And the other thing that you can do once you have that is all of our demo images are configured to run out of the box. So they automatically boot up a Storyboard application. And if you go to the user crank directory, there's a few folders there for you. And I'll try and make this a little bit bigger there. So you can see there's an apps directory, runtimes, SCP, and storyboard.scp. underneath apps, it's what you would expect. We have a couple of directories there. Under the nano, this is one of our launcher applications. There's this .gap file, which we're going to see shortly. Under the runtimes directory, this is where our embedded runtime lives. And what you'll see in the installation directory is there's this Linux, IMX8, Yocto runtime. But if we also go to the file system I have here, we have this engine directory, 6.2. There are runtimes for other supported platforms. So maybe you're not running on an IMX8. Maybe you're running on a TI board, one of the Satara series or the J6. We have runtimes for that here. Maybe you're prototyping on a community board. So we also support the Raspberry Pi. We have that runtime as well. We have runtimes that support OpenGL. So you can see here in the name, OpenGL or software render, which is using the CPU to render. Other operating systems, QNX, embedded Windows, you see Linux, but the other interesting thing is you also see this Win32. So that's the runtime that's actually built to run on my desktop Windows machine. So, all that's happening when I simulate the application is our tool is executing this runtime, and there's a binary available there, the sbengine.exe, and it's passing a few pieces of information to it. So all of these directory structures are the same. So, if I were to go back and look at the IMX8 one, they all contain the same structure. So all you need to do is drop that runtime on here. And in our case, the demo image is already configured. And then from there, you can write a script to launch it. In our case, we've provided one that actually you can use to launch an app if you want to deploy it over network and SCP. So if I just quickly cat what's in there, Storyboard SCP, there's a few things that happen, and each board is slightly different, but the core things that you need to keep in mind are we expect this plugins, SB plugins environment variable to be set, and that just points to the plugins directory of our runtime. And we also expect you to add the libraries to the LD library path. And those are the basic elements. So when those are exported, you can then call the engine directory, which you can see here is under the bin directory SB engine, pass in some options. In this case, we've set full screen on our device, and then the path to the application. And this is configured so that after we deploy something over SCP, we're going to pass that explicit path, but that might look something along the lines of, under our apps directory, it might be the path to this gap file. So those are the elements that you need to launch an application, and our documentation goes into much more detail in regards to this. But if we go back to our Storyboard designer environment, I'm just going to make sure I have the IP address there. Perfect. If we go back here, we can actually take this and export it and run it. So if we go to our export configurations at the top, so near the Photoshop icons, I can go through and start configuring our application. So the packager we want to use is this GAP packager, but if you wanted to export to an Android device, you could do that as well, or a standalone EXE. And again, depending on what platform you're using, you might select different options. And of course, we have lots of information about that. But the standard one is this GAP export. We also have the ability to create multiple resource configurations. So maybe you didn't want to include all of the images that come with this application. You could create other ones, but for now, I'm just using the default, which is going to deploy everything. And the transfer mechanism. So if you didn't select SCP, we would simply export that GAP file, which is sort of an exported version of our model that contains the images, the coordinates, the animations, stuff like that. But it would just be deployed to our project directory, which lives in our navigator. But the final step is, we're going to take that, deploy it over SCP. And we need a few pieces of information for that. The first being the IP address of our target board, username and password. So this is depending on the board and how they're configured, but most of our demo images out of the gate, standard stock Linux images have that root, that horribly insecure paradigm for evaluating, but those are in place here. And then finally, the output directory. So again, if we go back to our board and we grab the directory, so user crank SCP, copy that. This is where we want to deploy our application. And finally, the path to our script. So again, what script we want to execute after we've transferred the files. So if I go up one directory, if you remember, we have that storyboard scp.sh. I can paste that in there. So user crank /scp. I can hit apply, and then I can go and I can run that. And I'm going to hit run. It's going to deploy everything over SCP. And then I'm actually going to enable my webcam very quickly for you. Just make sure I have the right settings here. Webcam. All right, so we have the webcam. You can see also everything was exported properly. So I'll just stop showing the screen so you get a better view of the tool. But now we have our application. You can see here I've got my touch events already hooked up, my animation, so my menu pops in and out, my navigation between screens, fading in and out nicely, our security panel, all of that. So, a few different clicks and, a couple minutes spent, you've got a pretty interactive high fidelity prototype at this stage that you're playing with and interacting with on real embedded hardware. So that really is some of the power that comes with using Crank Storyboard. And this way you can get your design and your application in front of people quick for feedback. You can test things out, you can make changes. If you think about some of the other packaging options we had, maybe you export to an Android device, pass a tablet around a meeting room. That's a pretty powerful way to get direct feedback on your design and get it in users' hands so you can test and iterate and come up with interesting concepts and designs. So hopefully you guys found that interesting and valuable. I'm just going to quickly close off the webcam here, go back to the slide deck. Minimize that. So, kind of our last piece here. So, again, this is where we really encourage any questions, comments, but by all means, play around with the tool, sign up for an evaluation, test it out, prototype it. We have got a lot of other pieces of information. So we've got documentation about how you can design your files in Photoshop or in Sketch, if you will, how you can interact with some of our samples, but we really want you to play with the tool. And if you guys have any questions here, or if you've posted them in the chat, this is where I'll take a moment to answer them. But yeah, we want you to play around. We encourage you to experiment and prototype, and really excited to hear about some of the projects you guys are working on. Alrighty, so I get the feeling that I think we've sort of hit the end of questions today, but I'll leave it open for a moment longer. And if you have a question that you think about after the fact, by all means, feel free to reach out. You can contact support@cranksoftware.com. You could also reach out to myself, and Schultz@cranksoftware.com. If you have any questions, I'm happy to help and engage with you. And if you are building up a project or want to talk about other factors, you know, we are a product and services company, so by all means, we're here to help. So don't be shy, reach out, and have yourselves a wonderful day. Thank you very much for your time.